Hi, I'm Daniel Black. I am presenting here from sunny, well, in the daytime Canberra. It's the middle of summer here, and it's nice time to be here at FOSDEM remotely. So I'm here to talk about MariaDB Platform as a Service using Systemd. And this has got a place in my heart because this is actually one of the first larger bits of work that I actually started work on at MariaDB while I was doing database consulting and not really getting paid to do development. But it was a fun way to start and ended up where I am today because of it. So if we look at how this relates to the cloud stream that we're in, we may consider that like platform as a service is like this historic thing. And in fact, the open source platform as a service, it's listed here as like 9 years old, 10 years old on that. So what we're here to show is, some of the concepts that apply to cloud native are also applicable in the open source platform as a service model, and just another way to do it. If we look at what cloud native actually aims to achieve, and this is from the CNCF definition, is loosely coupled systems on resilience. It's about having services that are manageable, and it's about being able to observe individual services and also the robust automation of this. And we'll get back to this later and see how well this Systemd implementation maps up to those. Many in the past, and it's still available as an offering. In fact, cPanel still does it for its users, is provide MariaDB on shared hosting. And it's a trade-off. It's really good for simple installations. It's got database and privileges and user separation to ensure that at a base level, the privacy of each user is actually protected. However, it's got some weaknesses that it's a single MariaDB process running. Its settings are either global or session. There's no per database or per user setting for various things unless you want to change the settings on each session. MariaDB has a number of shared items, i.e. the table cache, InnoDB threads, InnoDB history, all the fsyncs that sort of happen to ensure the durability. Those are kind of shared items in the backends. And if you're ever on a shared hosting with an evil person, they've got the potential to disrupt their other users. So it's a cheap, simple option, and it, for the most part, serves its purpose. If we look at how Systemd's story in MariaDB started off, it started back in like 2015 when I wrote like the type equals notify changes into MariaDB to ensure it starts up in a cooperative manner with Systemd. For a couple of years afterwards, there was compatibility packaging problems. Everyone wanted SysV and SysD at the same time, and the interoperability between those wasn't great. Finally, that got resolved after a lot of displeasure, but I think that was a general sign of the times anyway. In 2017, at the end of that, I finally got committed into MariaDB in 10.4 series, the flexible MariaDB multi-service that I'll show one example of today. At the same time that was going on, and realized that there were some changes actually needed in Systemd itself. And part of the problem with MariaDB is that as a database service, when it's starting up, it can take a a while if it kind of got killed off hard to roll back all the transactions that weren't actually committed. And that delay is rather unpredictable. So the 90-second systemd default that was at the time could quickly get exceeded, and it's sort of not up to the package to try to guess as to how long that is. In fact, even like the sysadmins of such services would probably get surprised if the service didn't actually start up in that time. But what they'd be more surprised is that it was that far into processing and then got killed off, which is not what we want to happen. And so into systemd we added a bit, I added a bit that sort of enables the typicals notify message services to communicate to systemd to say, hold off, I'm still going, I'm getting closer towards an outcome on that. And so that cooperative approach has been there for quite a while. If that somehow fails, the failback in MariaDB and other database servers is to have a send sig kill equals no setting. And that's because you generally don't want your databases to hard fail, because that just means they're going to spend longer on recovering and rolling back stuff when they start up. What this meant was that you can actually have systemd that's actually forgotten about a MariaDB service because it's past its timeout, and there was like an option that says don't kill it, and at which point another service can actually start up. And it would be bad if that actually occurred at the same time as the other one's trying to clean up itself before getting out. So we prevent that. There's mechanisms within MariaDB that sort of prevent that kind of race condition, but let's not present sysadmins with two processes that they don't know which one to kill off. And this kind of concurrency and lock prevention to ensure there isn't multiple services applies on cloud services as well. So eventually we'll need to see how to interact those mechanisms with whatever the cloud mechanisms are for that. To run multiple instances of MariaDB at the same time, we need obviously a separate data directory, and we need a unique TCP socket and or a unique Unix socket at the same time. If we look at the systemd multi-instance implementation that got merged into 10.4, there is an initialization phase in the exec start pre, and an execution phase, which is when it actually starts a service. Both of these have an environment variable, MySQLD multi-instance, and both these programs actually take largely the same arguments, so it works quite well that way. Just write them that way. So let's get on with this demo. So first of all, we're starting with a Fedora 32, and we've got MariaDB installed from the MariaDB repos as opposed to the distro ones. Our login defs we've actually manually altered. I've put a minimum UUID of 10,000, and we've done that because we're going to use that as the port number. Also note at the bottom, I've got create home set to true on that, just for simplicity. So in addition to creating users, what we're going to be doing is ensuring that each user has their own configuration file for MariaDB, and we've created a little template here, and we've made the user the port and the user part of the template, and this will get populated by the system D overlay script here. So this is the extension of the default MariaDB service definition. The default server definition is a group by extension, and here we're going to group by the username. So we've set the user to %hi, which is the name of the service, which you'll see soon. We've done protect home as false to work past the previous security mechanism. As before, we've got MySQLD multi-instance as the environment variable that controls the installation and execution on both of those. We start an exec start pre list, and this blank line isn't actually a mistake. It's to reset the systemd service level back to default rather than extending the existing one in the definition. Our first line obviously checks if the file exists, and if not, it creates a file from the template. It creates a data directory, and it does a MariaDB install with the default options on the data directory. It's also creates the data directory with an authentication of type of socket, and what that means is only the Unix user of the name is actually able to access this instance. So we're protected against rogue users accessing each other's databases on the start, even without a password. And of course, the root user becomes the username of the service. Got restart always at the bottom, basically so the user can quit out and reinitialize their database service if they so desire, and I'll demonstrate this soon. So now that we've got that configuration file, we tell systemd to reload it, and then we can create our users. We add, Tom, Mary, Jan, and Fran, and then we start the services for each of those users. So here's where the app %i comes in. For Tom, Mary, and Fran, it's just mapped across that way. If you have a look, we can see that we've got 4 MariaDB instances running, and if we look at Tom's home directory, we see the data directory populated, and also a my.cnf file there. If we look at that for Fran, we can see that it's up and running, and that the service file is started, and the last bits of the logs for the service. If we look at the journal control-u MariaDB at Fran, we can see the entire installation logs from earlier. If we change to the user Fran and connect to the database as Fran, we see that ID is 10,003, so that's the port number that we were connecting on. If we select current user here, we see we're connected as Fran by default, and if we show grants, we see that we've got all privileges on the database. The default super user is Fran. It's got a MySQL native authentication, but it's got no password set, and the alternative is the Unix socket, which we've actually connected on. So a user could actually set down a password. As we said before, that because they've got all privileges, they can shut down the database. And if we look at the uptime, it's disconnected. And we look at it again, and it's restarted after 5 seconds, which is the default for that, just to avoid storms of restarts if things go wrong. So that covered the normal systemd service frameworks. And so what I want to actually talk about now is the socket activation, which is now got this fancy new word called serverless associated with it. And so we achieve this with a one-line file, i.e. this one, that sort of says there's a abstract Unix socket to listen on. And that's all that's required. And so now instead of starting MariaDB at tom.service, we start the MariaDB at username.socket. And so what this socket does, it's automatically there and listening, as you'd expect they to do. But at this stage, the service isn't actually started. If we look at systemd on an LSOF, we see that systemd is actually listening to these sockets, and when it gets a connection on one of those, it will actually launch the service. And it launches service by not actually accepting the connection, but by passing the file descriptor where it was listening to the service process on there. And when MariaDB is up and ready, it will actually start the connection. So we see this when we connect on, say, one of those sockets. We'll see the MariaDB at Tom socket socket is now in status active and running, as opposed to active and listening, which it was before. And if we look at the service status below, we see that it started up the service. And the mapping between those is purely based on the overlapping name between the multi-instance socket and the multi-instance service. So that's why we didn't actually need to change the service at all. So this is still work in progress. As I said, the socket is actually passed into the service, and that means we've got to do a few funky things to say, well, we don't open and bind to a socket. We just take the socket file descriptor as is and continue on. And so I've picked up my work that I began 5 years ago and am continuing on, and we'll get that merged into 10.6. So if we look at systemd against the multi-instance versions that we've discussed here against the cloud requirements, we see that we've largely got a loosely coupled service. They're independent services in that they're running on their own user. There's the same binary and the same libraries for all of the users and the same OS. So in that sense, it's not as loosely coupled as the cloud container world, but it's definitely simpler in that way. We've got resilience in that each process could kill or be died off in a separate way. We've got the ability to apply controls over each service. For instance, you'd probably run a memory limit for each of the services to ensure the users don't exceed those, and you've got can do disk quotas and IO quotas. And I forgot to mention all the MariaDB, all the systemd services are running in their own C group. So we've got a huge range of controls available now for setting those. And that can just be part of your systemd template, exposes most of those anyway. On resilience, we've still got the hardware and the OS as a single point of failure, but we've got independent services. On manageability, we can sort of create users and start a service exceptionally easy on those, so it's sort of ready to be automated that way. If we look at observability, we've got each user actually generating their own logs in that way, and we've got distinct C groups for monitoring and resource control. And we've got the ability to automate it. So, have you got any questions?